Okay, we're going to look at practice A and we're going to do number 1. Now we're going to go beyond what the problem asks because I just want to show you how circuits are so great and you can check your work all along. So whenever you have a problem, you can check your work and there's going to be a variety of ways and I'm going to show you. So it says a 12-volt storage battery. So I'll write down my given. And the total voltage, because that's the battery, is 12, is connected to 3 resistors. So I'm going to number them. If I don't number to keep track, that's how I make a mistake. So first of all, you need to, I'm not going to give you credit for your homework unless you do a schematic diagram for every problem. So R1 is equal to 6.75 ohms. R2 is equal to 15.3 ohms, and R3 is equal to 21.6 ohms. So the question says to find, A, calculate the equivalent resistance. So your book calls it equivalent. Some places call it something else, but I'm going to just call it T for total. It makes it easier. And then it says find the current in the circuit, which would be the total current. So first I'm going to draw my schematic. So when I draw my schematic, I'm going to have 3 resistors. And again, it doesn't matter. So I'm going to label them. R1 is 6.75 ohms. R2 is equal to 15.3 ohms. And R3 is equal to 21.6 ohms. And again, it doesn't matter if I drew them like this. In series, the current that's going through is the same. So VT is 120 volts. So, and this is, so that's 1, 2, and 3. So as long as you have the same current going through all 3, they're in series. Okay. So this is my given, this is my find, and this is my schematic diagram. And again, if I drew it like this, it wouldn't matter. That would be the same thing. All right. So the first thing it says is to find the equivalent resistance. So for series, RT is equal to R1 plus R2 plus R3. So I'm just going to say 6.75 ohms plus 15.3 ohms plus 21.6 ohms. So then on my calculator, I add those up. 6.75 plus 15.3 plus 21.6, and that comes out to be 43.65 ohms. So that's equal to my equivalent resistance. In the next part, it asks me to find the total current. So I'm going to be using Ohm's law, V is equal to IR, but if I just found the total resistance and I'm given the total voltage, then I'm going to can find the total current. So now I'm going to apply Ohm's law for the whole circuit. So I is equal to V over R, and I'm going to call this IT is VT over RT. So VT is the battery, 120, over RT, which is 43.65 ohms. Oh, this is 12. Whoops. 12. All right, so 12 divided by 43.65 is equal to 0.275. So the current coming out of the battery is 0.275. But you know what? I want to check my work. So they might ask you in a problem, find the voltage drop across this resistor, or this resistor, or this resistor. So we're just going to go ahead and do that. Okay? So, even though they don't ask me to do this, I'm doing this to show you how you can check your work. So if I found the voltage drop across the first resistor, now I'm going to apply Ohm's law to that one resistor. So I'm going to say V1 is equal to I1 times R1. Now remember, in series, the current is the same. So IT is equal to I1 is equal to I2 is equal to I3. So the current here is going to be 0.275 amps times R1, which is 6.75. So the voltage drop across the first resistor is going to be 1.86 volts. So V2 is going to be I2 times R2, which would be 0.275 amps times 15.3 ohms, which comes out to be 4.2 volts. And then V3 is equal to I3 times R3, which would be 0.275 amps times 21.6 ohms, which comes out to be 5.94 volts. Now, the great thing about physics is you have a foolproof way to check your work. So, in series, I hope everyone's looking at this and not working ahead, because I'm teaching you a foolproof way to check your work on every circuits problem. So in series, the voltages add up. So VT should be equal to V1 plus V2 plus V3. So now I'm going to check it. I'm going to add these up, and they should come out to be 12. Now, because these aren't even numbers, when I'm like approximating here, it might not come out to be perfect, but most of the time on the test, we're going to do where they're whole numbers. It's just in your book, for some reason, some of these problems, no one usually does 6.75, 15.3, and 21.6. So when I add these up, they should come out to be 12, which is the battery. Okay? So I have a foolproof way to always check my work in circuits. And if you don't do it, then you're the fool. Okay? Because you can check every single problem by doing this. Okay? And that's it.